Hello. Welcome to Oli Garden's live stream. This week, we're going to talk about bad telemetry. My name is Juraci. I'm a software engineer, and I've been doing telemetry systems for a while now, since 2015 or so. And since 2019, I've been part of the Open Telemetry project. And since the beginning of the year, we are doing Oli Garden. So Oli Garden is we have the mission of making telemetry pipelines more efficient. And for us, the beginning of the telemetry pipeline is where telemetry is generated. So it is close to the application. And that's why bad telemetry is so important to us. For us, we can only have an efficient telemetry pipeline if the data that is flowing through the pipeline is of high quality. So that's why bad telemetry is such a big problem for us. If we have bad telemetry flowing through the pipelines, then it's a bad telemetry pipeline. Then and once we explain what that we are handling the problem with bad telemetry, the next question that we have is inevitably, what is then bad telemetry? And this is a question that I hear so often that last month or so, a couple of weeks ago, I presented at the Datadog user group here in Berlin, and the topic for the presentation there was, what's bad telemetry anyway? And this is going to be the topic for today. So today is a little bit different. And over the next 30 minutes or so, we're going to talk about what is telemetry at the beginning. So what is bad telemetry and so on and so forth. And then I give you some examples. And we talk a little bit about what we are doing at Oli Garden to solve the problem with bad telemetry. So what is Oli Garden? Oli Garden is a company that we started at the beginning of the year with the goal of first addressing bad telemetry. And over the past few weeks, we've launched a few products. So we launched the first product in June, and we onboarded a few our first users over the past few months, and we've been seeing what bad telemetry is out there. So we are seeing a lot of the bad telemetry that is in the real world. Before that, the theory that we had and the experience that we had was that there was a lot of bad telemetry out there. And one thing that we heard from people in our circles, a CEO of an observability company, was up to 90% of the data that they received, so concretely data that they received, was never used, was never queried, was never used in a search or a dashboard or alerted on. It was just garbage. And that's the kind of problem that we see. So Oli Garden provides an insights platform, so we show you where bad telemetry is, so you can go back at the source and fix the problem. Towards the end of the session here today, we're going to show you a couple of other things that we are building so that we can automate this process of fixing the problem. But since June, we've been focused on giving you the insights about what is bad telemetry. All right, so given that introduction, so this is an interactive session, right? So if you have any questions at any time, just write down here in the chat. If you are on LinkedIn, then don't forget to follow the page of Oli Garden. And if you are on YouTube, don't forget to subscribe to the channel. All right, so it helps us a lot if you do both. Like if you follow the page and if you subscribe to the YouTube channel. All right, let me share my screen then with you. Let's see if it works here. Share screen, window. I should have prepared this before. And there you go. Cool. Okay. All right, so there we go. So what is bad telemetry anyway? So, are we on the right? Yes, we are on the right one. Cool. Okay, so what is bad telemetry anyway? So I introduced myself, but formally, my name is Juraci. I'm a software engineer here at Oli Garden. I'm also part of the governance committee for Open Telemetry. I'm a CNCF ambassador, and every couple of months, I like to organize hotel night here in Berlin. So if you are in Berlin, the next one is going to be at the end of the month. I think it is November 28th at the offices of SAP. So just go to the CNCF events page, look for the Berlin chapter for for the Cloud Native group, and we have an event there. I was a maintainer of Jaeger in a previous life, and since recently, and until recently, I was also a maintainer of a few modules of the Open Telemetry Collector. During my free time, I like to create content both in Portuguese, which is my native language, and in English recently as well. So the English content, the English channel is called Telemetry Drops, and it's also available on LinkedIn and on YouTube. And if you speak Portuguese, then there's Dose de Telemetria for you as well. All right, so let's get started with what is telemetry, and then a little bit about instrumentation, and then telemetry, and finally bad telemetry and how to fix it. All right, so what is then telemetry? What is the thing that we keep talking, like what is telemetry? And telemetry is nothing more nothing less than just the data that is generated by your application informing its internal state. Right, so telemetry is the kind of the data that is not your business data, but it is the data that tells the outside world what your application is doing. So what is what is the state of my connection to the database? How many messages did I process? How many requests per second am I having? And that kind of information, that is telemetry. And typically telemetry is, we as developers, the first thing that we learn is print hello world. And that's kind of a log, right? And so logs are the very first signal, the very first type of telemetry that we learn and that we start using. And then we have also other types of telemetry, like metrics or traces, or perhaps spans. Traces are a collection of spans. Or perhaps events, or perhaps profiles. So events, profiles, they are not as common. I mean, events, they don't necessarily live within the application. The events are, for instance, when I changed my config file for the last time, or when did my last deployment happen, or was there a DNS change sometime. Those are events that may affect my application, and I need them to understand what is going on with my application. Without them, I have a blind side. I have a blind spot. And profiles, and while traces, so traces, they are a picture on the horizontal of your transaction, of your application. So a request comes in and it flows through a lot of services, and then it does its job, and then it returns to the user. That's a trace. So when you're able to get the breadcrumbs of that transaction and see the transaction as a whole, that's a trace. And a trace is made of those breadcrumbs. Those breadcrumbs are called spans or operations, or perhaps even events in some platform, just to confuse things a little bit more. And profiles, while traces are a picture on the horizontal, profiles are a picture on the vertical, meaning that we have a snapshot of a moment for that specific instance of a specific application. So if we have like 5 replicas of our application, we take a picture and we see the memory and the CPU at that specific state. Right? We can take, of course, a lot of pictures and compare the pictures, and then we have continuous profiling. But profiles are a different signal as well. So those are the telemetry types that we have at our disposal. But how do we get there? How do we get that telemetry out of our application? How do we create logs and metrics and traces or spans? But what is instrumentation first? So instrumentation is code that generates telemetry from our programs with the purpose of enabling humans and agents to understand application behavior at runtime. So my definition of instrumentation before didn't have the word agents, but as of recently, we generate telemetry more and more so that agents can understand the behavior of our application at runtime. So how many AI SRE companies are we seeing out there? And they thrive on good data. They thrive on good telemetry. So doing telemetry for humans and agents is a good way of generating telemetry, right? So we do instrumentation so that we have good telemetry. We have telemetry for humans and agents to reason about the state of an application at runtime. All right, so how do we do that? So logs, quite simple. You probably know logs already, so let's start small here. And this is a log that is this is a structured log, right? So this is a log that contains a message, and the message here is starting gaps. Those are real code. So this is code that I got from Oligarden itself, right? So this is code that I copied from Oligarden. Every service that we have internally here at Oligarden has a kind of a botanical theme. So we have a service called Gaps, we have a service called Hummingbird, and we have a service called Chaff, and so on and so forth. So, and this is a log with a message, so starting gaps. And then we have a set of key pair values, key pairs, key value pairs. Now, there you go. So we have a string version, and then a commit. What is the commit SHA? And then when is the date that this program was compiled? So this is all information that we can add to our log record. And version, commit, and date, there are fields in that log message, so we can then later on, depending on our backend, we can filter by those values. I'm sure that you know about structured logs. I'm confident that all of you are doing structured logs already. Nobody's doing unstructured logs as we were doing in the past. Everybody here is in the future, right? If you are not in the future, leave a message here in the chat. I want to see how many of you are doing structured logs and how many of you are not doing structured logs. All right, so that was logs. And what about spans? So this is one way that we can generate a new span. So in this case here, we are starting a new span called consume, and then from where we're consuming messages. So this is a message queue kind of pattern. And then we specify what is the span kind. So a span kind consumer. And then eventually, at the end of this function, we close the span. So what it does is it measures the time that it took for an operation to execute. In this case, how long this method has taken, right? So this is a Go code. So the fur means before the application, before the function returns, the span.end is going to be called. So this is very useful to measure how long a specific operation is taking. And for metrics, we, again, this is also using OpenTelemetry. So what we can do here is we initialize a metric, and then we store the instrument, in this case here, operation duration. And then whenever we have a new reading for that, we call the record function, or we call record, and then we pass all of the information that we have about that specific operation. And then that metric gets aggregated in some way and sent to a backend somewhere. Now, this is the way that I do telemetry. So all the examples that you've seen here, they are real examples from the Oligarden code base. I prefer to do manual instrumentation. I can be very tactical. I can be very purposeful. I can see what I need and declare. But it's for most people, it is tedious, right? So it's not something that is very exciting to write. It's not AI, right? So it's something that you have to think and you have to stop and think about that while you are doing development. It has a learning curve, right? So I have to learn a whole set of APIs, like OpenTelemetry APIs and so on. So it does have a learning curve. And typically developers, they don't like instrumentation alongside business code. So they see the business code as that pure place where code is happy and there should not be any logs in that, no traces or anything that doesn't belong to the code. Now, I would argue, and very vehemently, that telemetry is business code, right? So one of the things that I like saying is the code that you write today, it keeps running over and over again. It keeps running 24/7 for months, for years. And you only look at that code for, I don't know, 10 minutes, 20 minutes, 1 hour over the lifetime of that code. So telemetry is part of the business. It belongs there. Your code needs to be more observable than you look at the code. So the behavior of your code, the behavior of your application is more important than the time that you spend looking at the code, right? So I would argue that the place for telemetry is alongside your business code. Telemetry is business code. Anyway, this is a side note. And with that said, we then go to telemetry. So let's imagine that we are in a future where we trained all of our developers. They all fell in love with instrumentation. So they are doing the perfect instrumentation. But then they learned telemetry so much that they are instrumenting all of the method calls. I've been there. So the moment that I learned instrumentation, back then with open tracing, the first thing that I've done was instrumenting all of the method calls, and that's not the right way to do things. Or we use inconsistent attribute names and values for the same things, and that's actually so this is perhaps not so much of a secret, but this is something that we face at Holy Garden ourselves. So we face an inconsistent attribute names for our code, and not only us. Right. So at companies that I was before, there were the same or different names for the same things, like cluster. There was a cluster underscore name, or a cluster name, or just a cluster dot name, or just cluster. Right. So all of those different names, they can be seen as attributes for the metrics, for the spans, for the logs. So it's easy to get inconsistent when we are doing manual instrumentation. And it's also common to reinvent wheels, and specifically or especially the semantic conventions wheels. So semantic conventions are a database of conventions where it says when you are instrumenting an HTTP method, then you should use attribute names blah, and the status code has to be this name, and the value has to be an integer, and so on. So like those are the rules for good instrumentation, or for the names and values, so that we can speak the same language, so that my application, my telemetry, can get out of my application into one backend, into another backend in the future, and they understand our telemetry the same way. So that's the semantic conventions. Now, what happens often is people don't learn the semantic conventions as fully as they should, and they end up reinventing the things that exist at the semantic conventions level. So this is one of the side effects of doing manual instrumentation. So we train our developers, and then eventually we end up with problems like those. And that's not a comprehensive list of problems. It's just one small sample of the things that we've seen out there. Now, the alternative to training our developers is to not train our developers. So if we don't train our developers, and if we provide them with tools like Java agents, .NET instrumentation, or eBPF instrumentation, then we end up having a lot of data. And because that runs at the base level, that doesn't run at the application level, that typically runs at between the platform and the code, or in case of eBPF, it's even like 1 or 2 layers down. It doesn't really understand the business. It doesn't really understand the difference between a /payments and a /health check endpoint. So at that level, they're all the same, and they end up capturing a lot of telemetry. And because they don't know what to collect, they collect everything. And it's not to say that they're wrong. They're not wrong. They're collecting data because they need to collect data. That's the business of the Java agent instrumentation and .NET and eBPF instrumentation. They cannot know what is good and what is bad, so they just end up collecting things. And eventually, we have to filter those things out and remove them. But that's how we end up with bad telemetry. So bad telemetry is both caused by manual and auto instrumentation. But when we do auto instrumentation, the auto capture is dangerous. We end up having things being captured that we have no idea about. So things that we've seen here at data that we are receiving at Holy Garden. So we are seeing URL queries often containing PIIs or sensitive information like access tokens. And those are things that the auto instrumentation is capturing by default. It is a huge net that those tools are throwing and gathering a lot of data from there. And among that data is PII. Among that data is we find passwords, we find access tokens, and things like that. So that's bad telemetry, right? So it's not necessarily that it's voluminous, but it is it contains information that should not be there. Other things that we've seen, it captures command line arguments, and those might contain passwords. I know it should not be there. We should not use passwords as command line arguments. but people are doing that. We've seen it, especially JVM trust store passwords. Like some people, they think it's a good idea to pass the trust store password for the JVM in the command line environment. Nobody's going to see. If one thing that I heard in the past was, if an attacker got access to the list of processes of a machine, we have bigger problems. But what they are not counting with is that there is a process on that machine that is capturing that and sending data out, right? So the attack vector here is a little bit different. Or perhaps bad telemetry is because it does record too much, right? So one example that I've seen a trace in some time ago was I was looking at a trace where they were showing a database, a trace for a database call, like a SQL statement, I think, of sorts. And on that trace, there were a lot of spans for locking things and unlocking things and locking and unlocking. Like, why do I care? Right? So as a developer, why do I care about every single lock that every single query that I'm running is doing? Like, this is not important, not relevant for me. So that's a lot of information, a lot of garbage that I don't care, that should not be there. So that's too much data. And useless data. Like, I really don't need a trace for every single call to my static assets like CSSs and JavaScripts and images and things. I mean, I don't need that. Or health checks, right? So health checks are one of the most common sources of telemetry. And it's typically, or usually, most of the health checks are useless. They are just the same things happening over and over again, and they almost always return a 200 status code. So we should probably not have all of them being grabbed. So this is one example of bad telemetry. This is a health check, right? So we are having a health check. This is a 200. This is really not necessary to have this one span in here. We can just throw it out, and it's not going to make us our debuggability or observability better or worse. It's, if anything, it makes it better because we don't have too much noise to sift through when we are like 2 a.m. in the morning, look at our telemetry to understand what is happening, what is going on in there. Another bad telemetry that we have is this one. Like, we have an access token in the URL query that we are receiving. So in this situation here, I was analyzing this trace the other day. This is from, again, one of our users here at Oli Garden. And the situation is that specific service received a request from a user, and the user was not authenticated. So they went to an IDP, an identity provider service. And that IDP returned back to the original service. And then on that path, it sent an access token. And that access token was captured by the Java agent. And from the Java agent, it just grabbed wholesale. Like, what is the full URL query? It's a good idea to store the whole URL query and send out to whatever backend we're using. And this is really not a good idea, right? This is, I think, doubly encoded. So there is a value attribute, and within the value, there's a encoded URL. So it is doubly encoded. So it's hard for SIEM or traditional SIEM tools to capture. But because we understand open telemetry specifically, we understand that kind of data, we know what to look for. We know where to look for data. So we were able to find an access token in a URL query within a span for a specific situation, for an HTTP call. All right, so how do we go about fixing it? We can fix it in different ways. One of them is fixing at the source, right? So if we find that there is a high cardinality metric somewhere, we can go back to the code and we can remove the high cardinality attribute, and that's it. It's easy. The problem is finding that problem. So fixing, it's typically fine. But even if we are talking about a legacy application that doesn't, we don't have this access to the source code, what we can do is we can add within our collector. So typically we would have a collector between our applications and our backends. And in that collector, we would install a transform processor that would do the transformation of every single telemetry that is passing through the collector redacting data. So what we can do is we can just drop URL query altogether, right? So for people who need URL query, then they could selectively parse that information and then add as specific span attributes. But at wholesale, it's a bad idea to store the URL query. Or perhaps they could do a tail sampling of the health checks. So they keep 1% of the 200 status code health checks and keep 100% of the health checks that failed, the health checks with the 500 status code. So that's possible with tail sampling. So you can do that. You can fix bad telemetry, both at the source code and at the collector. Now, a different way of fixing that is what we are doing with Rose. So Rose is a product that we launched, research preview. We launched it last week, and Rose is able to look at the insights that, or will be able to look at the insights that we have for a specific service and propose changes for you. What Rose can do right now is you can install Rose in your GitHub repository, in your GitHub organization, and for every single pull request that is opened against that specific repository or in repositories within that organization, it can judge the PR. It can judge the instrumentation within that PR. So I've been using, we've been using Rose at Holy Garden, and whenever there is a new PR that we add instrumentation or we change instrumentation, Rose comes in and says, this span name here is not good, so change to X, Y, and Z. And then we have an idea on what is good telemetry. And the good thing about Rose is it doesn't just tell us what is wrong. It gives the whole context. It gives the whole reasoning. So our knowledge about why a good span name makes it a good span name, that is part of the knowledge that we've given to Rose and that Rose is providing as part of the pull request review. We also have Tulip. So Tulip is a product that we launched a few weeks ago, and Tulip is our distribution of the Open Telemetry Collector, and provides a stable base for people to build their own collectors. One of the complaints that we've heard from people out there is that the collector is not stable enough, not in stability of runtime, that the collector is rock solid. But what people have been striving for is a base, a stable base for them to build their own components on top, or a base where they can run for longer periods of time. But if they find a problem, if they find a bug, if they face a bug or a CVE, then we backport those issues and we backport those fixes into Tulip. So you can keep running the same base level of the collector for longer periods of time without having to bump to the newest version of the collector to benefit from the fixes. Bumping to the latest version of the collector might be a good thing, might be what you need, might be what you want, but might also cause confusion. Like perhaps something else changed in your telemetry. Perhaps something else changed in your collector. Perhaps something else changed in the configuration of a component that you didn't expect. So you have to then fix a lot of other things than the thing that you are actually looking for when bumping the collector version. So that's what Tulip gives you. Tulip gives you a stable base to build your own collectors or to run a collector. And we have Holy Garden Insights. Holy Garden Insights is the platform that we show you the insights that we are seeing for your data. You send us some data in addition to the backends that you already send your data. So perhaps you send your data to Datadog, to Grafana, to Dash0, to New Relic, to Splunk. And you can send also some of your data to us, like 1% or 5%, or perhaps only the dev data. We've been receiving dev data only for a few users, and they are happy with that. I mean, we are happy that we don't see production data, but the theory there is if we see the instrumentation that we see in dev, it's very similar to the instrumentation in prod. So we can give you insights about your dev instrumentation, and you can apply that to fix your production instrumentation. All right, so we have here a couple of screenshots for the things that I've been mentioning. So this is Rose, and Rose is here telling me that there is a potential PII in telemetry. Rose is telling me that email addresses should probably not be on my telemetry. This is an example of how to use Tulip. So Tulip is compatible with OpenTelemetry Collector. In fact, it is built using the same tools that we use to build OpenTelemetry collector at upstream. Of course, the components that we ship with Tulip so they're not the same as the ones in Contribute. So you have to look at the components that you are using right now, and you either use Tulip directly, or you can build your own distribution based on Tulip. And we guarantee you that we give you a solid base for you to build your collection, your collector, and your components on top of. And insights, so this is an example of Early Garden Insights. We show you things that you don't know about your telemetry. So what I like to say when I'm talking about Early Garden to other people is, you can send us data, and I guarantee you, we are going to find something about your data that you don't know, and that thing is going to surprise you. All right, so a few key takeaways from today. The first one is bad telemetry is inevitable. So we are going to find bad telemetry in our observability journey. And perhaps the very first step that we have is we don't have telemetry at all. And then we are very happy when we have some instrumentation, when we have some telemetry coming out of our application. That's a moment of joy. But then the next moment is we realize that we might have too much telemetry. We might have some bad telemetry. My take is train your developers. Manual instrumentation or instrumentation closer to your code is the one that gives you the best return on investment for your observability. Doing the instrumentation at the lower levels, it is a very good stopgap solution. So if you don't have any observability at all right now, start with auto instrumentation. That can give you the space and the room for you to breathe and to understand what your application is doing. But on the long run, try to go closer to the code. Try to go closer to manual instrumentation. Again, rows can help you there, but you don't have to use rows to have good instrumentation. Rows can help you. And you can use tools to help you find bad telemetry. So one shout out that I can give here is to Weaver. So OpenTelemetry Weaver is a project in the OpenTelemetry community that helps you be more consistent on how to name things and how to use telemetry in your organization, how to apply the same rules consistently across different repositories. The Instrumentation Score project can help you and can guide you in showing you examples of what you should not be doing, right? So the Instrumentation Score tells you every single telemetry point has to have a service.name. So that is a strong opinion. That is an opinion from the Instrumentation Score project, and you can take it or you can leave it. But that's one guideline. That's one thing that you can look at and see, you know what, they are right. Or you know what, that one, I'm going to pass. Let's look at the other one. The other one, oh, yes, metrics with high cardinality. So I should be conscious, or I should think about that kind of situation when I'm looking at my telemetry. And Early Garden can help you automate this full process. Early Garden can help you identify where bad telemetry is and can help you fix the bad telemetry where it's happening. So that's what that's where Early Garden can help you right now. And no matter how, if using Early Garden's help or not, fix your bad telemetry, either directly at the source or before it hits your backend. More important than anything else here is clean up your data, right? So find your bad telemetry, fix your bad telemetry, no matter if it is at the source level or if it is at the backend. And one thing that I wanted to say as well is, again, Early Garden can help you identify the problems, guide you on fixes, and measure the improvement. And what we are announcing today is everybody can use Early Garden now. We've launched Early Garden in June, and we opened up Early Garden for a small number of organizations out there. We've been working quietly and getting people to use Early Garden so that we can see what is the bad telemetry that people have in the real world. Right now, we've seen enough to open up Early Garden to everybody. Everybody who wants to use Early Garden can go right now to earlygarden.com and click on the access to have access to earlygarden.app, so our Early Garden instance, and you can sign up for free for Early Garden Insights right now. What we are giving you is 2 insights for free for every service that you have. So you can send us as much data as you want. We're going to analyze your data. And if we find 2 specific insight types, we're going to tell you where the problems are. We can find more than 20 insights. Right now, we can find about 15 insights, but we're implementing more insights very frequently. And but 2 of them are free. And the 2 are PII detection. So we are telling you, we're going to help you in identifying where bad telemetry is in terms of PII. If we see something that looks like a PII, that smells like a PII, we're going to tell you. And then you can go there and fix the data in your systems. And the second thing is noisy data. So excessive data, discouraged resource attributes, as we call them. And those are resource attributes that we are very opinionated about. And we say, you should not use those resource attributes. If you have them, just get rid of them. For instance, why do I need the whole set of command line arguments for my metric data points? I don't need them. I'm never going to aggregate on command line arguments, or perhaps the list of IP addresses. So it is common in some auto-instrumentation libraries to capture the full list of IP addresses and MAC addresses, and they place them on the resource attributes for every single batch that you send out of your application. And that is bad telemetry. And that we can tell you how to remove if you send us data with that pattern. Those 2 patterns are free for everybody now. You can go to oligarden.com and sign up for Oligarden for free, and you can use as much as you want. And we're going to give you 2 insights plus the instrumentation score for each project. There you have. That's our promise for you. And if you're happy, and if you want to find even more instrumentation issues with your code, with your services, then you can subscribe to a paid plan by Oligarden. It's starting at $2,500. And for a limited number of requests per second. Go there to oligarden.com and look at the plans that we have there, look at the description of the products. But if you don't want any of that, if you want to sign up just for Oligarden right now, go to oligarden.app. And with that, so there are a couple of questions here in the chat, but I say to you here all, obrigado. And let's keep in touch. So if we're not connected on LinkedIn yet, so just go there and add me, send me a connection request, and I'm definitely going to accept it. But also follow the LinkedIn page for Oligarden on LinkedIn, and subscribe to the YouTube channel as well. All right, so we have one comment here from Rodrigo. So even in manual instrumentation, we don't need to instrument every single method manually. Exactly. What I usually do is use a proxy function in the classes, so the methods are automatically added to the trace. That's true. What I do is I instrument the boundaries, and that's it. So that's how I start. The boundaries are for a Go microservice, for instance, that exposes an HTTP endpoint. I instrument the HTTP endpoint. And then at the other side, like if I do a downstream call, or if I'm sending a message to a queue somewhere, then that's my second boundary, or go to a database. So that's my boundary. So before I leave out of this process, I create a span to represent that boundary. Now, that's typically what I do. And then we have internal spans. If there's something very, very important, let me remove the comment here. If we have something very, very important in the application, then we can be very, very conscious and very purposeful to create one span that represents that one critical operation within our application. But that has to be the exception, not the rule. What I typically do when I need to record something in between that is not at the boundaries is I consider adding an event, like a span event, or perhaps sometimes it can be just an attribute. So perhaps I can get the span from the context, and then I add a new attribute, and I say, well, this is the organization ID X, Y, and Z. Perhaps I don't have access to the organization ID at the boundary, but I do have 2 steps down. But I don't need to create a span 2 steps down just to get the organization ID into the trace. So I can just get the span context or span from the context or the current span in Java and add this attribute. And that's it. And let the transaction flow. So we don't have to create spans for every single thing that we have. Another question. Você é brasileiro? Sim, eu sou brasileiro. Yes, I'm Brazilian. Yes. Yeah, thank you so much for the presentation and for Oligarden. So take a look at the instrument, at the insights we have there. As I mentioned before, I can guarantee you that we can find something about your telemetry that you don't know about, and that thing is going to surprise you. And with that, I leave it for today. Next week, if you are at KubeCon next week, I'll be there as well. Let me remove the slides here from the screen. And there you go. Cool. If you are at KubeCon next week, so hit me up on LinkedIn, send me a message. I'll be there in Atlanta. If everything goes right, I'll be there in Atlanta next week, both for Maintainer Summit on Sunday, I believe. On Monday, we have Observability Day. On Tuesday and on, we have KubeCon proper. And I think that's pretty much it. If you want to talk about bad telemetry, if you want to talk about Oligarden, send me a message. Whatever you can find me on the CNCF Slack. You can find me on LinkedIn. You can find me in other places. Just send me a message and let's have a conversation at KubeCon. With that said, again, I invite you all to try Oligarden. Oligarden is now available to everyone. Try it out and send me your feedback. Tell me what you think about it. If you find any bugs, let me know as well. We are very good at fixing bugs. And that's it. And our next live stream, I believe, is in a couple of weeks' time. And so follow the Oligarden LinkedIn page to know when is our next live stream. See you there.